Let's talk a little bit about magnification factor. Filming on a conventional simulator, the target to film distance is always greater than the target to axis distance. You may see this sometimes as SFD or SAD, which stands for source to film distance or source to axis distance. This was more commonly known when there were cobalt machines or machines with sources, still used interchangeably today. It's also important to know that your film to focal distance is always greater than your film to object distance. You might see this sometimes as image over object size or object over image size when talking about magnification. So target to film distance being greater than target to axis distance. I drew a picture here. Don't laugh at my picture. Your target distance is located on the top and the film at the bottom. So if you look at your TFD, obviously that's always going to be larger than your TAD. So any object on the film is going to be larger because of divergence of the X-ray beam. If you look at an object in the patient or even sitting on top of the patient with the film being behind, by the time your X-ray divergence projects to the film, that image is going to project larger on the film. So real life, real objects are 1. Anything larger than that is going to be greater than 1. So if it's a true magnification problem, your answer is always going to be greater than 1. Your film to focal spot distance, which is the same as TFD, if you look here, that is always going to be greater than your film to object distance. Same principle as before. So on an exam, if it is a magnification problem, eliminate all of your answers less than 1. But be careful that it's not a minification problem. Take a look at your question. Try to figure out what it is that they're asking you, if it's truly a magnification problem or not. Sometimes it's helpful to draw a picture. Stop and ask yourself, what are they asking? What answers can be eliminated? Solve the equation, draw it out if you need to. But be careful, they're not asking minification versus magnification. For patient anatomy, we know on the film it's larger due to magnification. We know the approximate size on or in a patient by the magnification on the film. So let's take the first example. We know our target to film distance is 130 and our target to axis distance is 100. What is our field size at isocenter? We know that the field size on film is 17. If you want to pause the presentation, you can solve this problem. But basically, your magnification is 130 over 100, so it's a mag of 1.3. Normally, you would multiply that by 17 and you would figure out what your answer is. But that's not actually what they're asking. They're asking what's the field size at isocenter. So this is actually a minification problem. It's actually going to be a smaller number. So you're going to divide 17 by 1.3, you're going to get 13. Your field size at isocenter should be 13. But it's not a difficult problem. When you have this problem, you ask yourself in the beginning, if I know my image on film is 17 and they're asking me what is it at isocenter, well, I know it's going to be smaller at isocenter. So I know that my answer is going to be smaller. So right off the bat, when you look at your answers on a test, you say, I know it's going to be smaller than 17. So anything larger than 17 on the test, I'm going to cross those out. Because if you accidentally solve your equation wrong, you don't want to pick the answer that's larger than 17. Let's go on to the next problem. What if I asked you what is the image size on the film if the object at isocenter is 5 cm? So ignore the 17 cm down on the film. We know that our mag is 1.3. So if it's 5 centimeters in the patient, it's going to be 6.5. on the film. So that's a standard magnification problem. They will try to trick you by throwing in the tray distance. They try to throw that in a lot and add extra factors in there that you don't need. If it's a basic mag and it has to do with something on the patient and something on the film, that's all you need. If they were to ask something that was sitting up at the tray distance and what it would project on the patient, then obviously you would have to use that. Or so if it's something more complex, you still have to use those factors. But if we're talking about patient object versus film size, then that's standard magnification.